this problem, we're trying to figure out the force of gravitational attraction between two rods that lie on a straight line with a gap in between them. So this is the length of rod number 1, and this is the mass of rod number 1. Length of rod number 2, mass of rod number 2. A is the gap in between them, and R is the distance from rod 1 to any point on rod 2. We are going to split the second rod into small slices of length dr. The density of the second rod can be stated as m2 divided by L2, mass divided by length. So we can say that each slice of rod number 2 can be stated as mass divided by L dr. Now we have two distances to deal with in this problem. One is the distance between rod 1 to any point on rod number 2, and the second distance is the same distance plus L1. So we can say distance is R times R plus L1. We're going to use the formula for gravitational potential energy and substitute the information that we have gathered. Notice that the G is a constant and it's 6.673 x times 10 to the negative 11 newtons by meter square per kilogram square. Once we substitute our information into the formula, this is what it's going to look like. And now we integrate from A to A plus L2. Before we integrate, we need to isolate our constant, which are all of these items. And we integrate for dr over r times r plus 1, L1. I use the partial fraction method to integrate, and I end up with this integral. So I factor out 1 over L1, and I have a much simpler integral. So once I integrate it, I end up with G times mass 1 times mass 2 divided by the length of rod number 2 times the absolute value of ln of r minus the absolute value of ln of r plus L1 evaluated from A to A plus L2. Once I evaluate with my limits, this is what my equation looks like. It is very long, and it can be reduced to this. So G times mass 1 times mass 2 divided by length 1 times length 2 times the ln of all of this. I suppose it could be reduced a little bit more, but it will be a pretty long video. And this is my final answer.